So we start this linear programming problem. It is related to your operations research. What is linear programming problem? It's a 2-mark question. Linearity means a proportionality. Programming means it's a planning. And we are formulating as a problem. We have learned this in class 6 or 7. If one man can do a job in 3 hours, then 2 men can do the same job in 1.5 hours. So when you increase the number of persons, working time will reduce. It is inversely proportional. So this proportionality, what we call it as a linear, non-linear. This is a linear means it should be a straight line. Either it will decline or it will increase, something like this. Am I audible to you? Am I audible to you? Can you all able to see the screen?
Yes, sir.
Yes, sir.
So this is another important 5-mark question. Important 5-mark question for the examination. So solve graphically, they will tell you. How do we know the problem can be solved graphically? If a problem is based on only 2 variables x and y, x1, x2, then you can solve this problem by a graphical method. You can solve this problem by a graphical method. So we have to first see what type of problem it is. Check whether the problem is to maximize or minimize. This is a step number 1 to verify. It is a maximization problem. Subject to 2 constraints are there. Constraint number 1, that is 3x1 plus 2x2 is less than or equal to 48. Whereas this one is x1 plus x2 is less than or equal to 20. So both the constraints are less than or equal to type. And right hand side should not be negative. Right hand side should not be negative. Why? If right hand side is negative, what happens? This right hand side always talks about the availability. I tell you an example. To do a job, to produce product A, it can be done in 3 hours per unit. For 1 unit it is 3 hours. For 2 units it is 6. For 3 units it is 9. For I don't know how many units I am going to produce. Let it be x. That is why it is 3 into x. Likewise, product B, for 1 unit it takes 4 hours. For 2 units it takes 8 hours. For 3 units it takes 12 hours. For 3 it is 12. I don't know how many units to produce. Let it be y. Both added together, it should be within. Availability of the raw material is 1200. So availability of the raw material is 1200 means within 1200 units I have to manage. Within 1200 I have to manage. So this is what this constraint talks about. What is this objective function? So the LPP consists of 3 components. One is objective function. For what reason this problem is being taken? To maximize a profit or minimizing the cost. It can be either this or that. It can be this or that. Subject to the first constraint, it can be a raw material constraint. Subject to the second constraint, maybe a time constraint, like that. We can classify. So, step number 1, check whether the problem to maximize or minimize. Step number 2, check whether the right hand side is negative. If there is negative, what we have to do? Assuming if I have a constraint like this, multiply minus sign on both sides, then inequality will be reversed, so that we will get this. So when you multiply minus sign on both sides, inequality reversed. Why are we multiplying minus sign on both sides? Because right hand side should not be negative. If right hand side happens to be negative, then it is not logically correct. You know why? Because right hand side exhibits the availability. So how can availability be negative? That is why. So x1, x2 is more than or equal to 0. This is a non-negative constraint. That is, number of units what are we going to produce should not be negative. It could be 0 or more than 0. It can be 0 or more than 0. So first one, you take first we want to plot this inequalities in a graph. So this is said to be an objective function. These two are said to be a constraint. Constraint means subject to the condition. Just now I said within 1200 we want to decide how many units to produce in A, how many units to produce in B. So that is why I said it is a constraint. Now step number 1, it is a maximization problem. Step number 2, no right hand side should be negative. Step number 3, convert this inequality into an equation, then substitute when x is 0. When x is 0, what is y? Take x is equal, I mean x1 is equal to 0. What can be x2? X2 will be equal to 24 because 2x2 is equal to 48. Then x2 will be equal to 24. What about b? When x2 is 0, what can be y? It should be 16. Sorry, x1 should be 16. In the same way, you take x1 is equal to 0, x2 is 20. Likewise, if I take x2 as 0, x1 is 20. Have you understood these two steps?
Yes, sir.
So first one, we have to plot this line. So plot this line. First, what I should connect A and B. What is A? What is B? A is 24. A is 24. B is 16. So 24, 16 may come here. 24, 16 will be this. Just a minute. 24 and then 16. I have to connect A and B. It should be this. Then 20, 20. So this these two must be connected. C and D. C and D to be connected means it will be like this. So first we have taken this one. I suppose have you understood the lines what we have drawn it.
Yes, sir.
0, 24, 16, 0, 0, 20, 20, 0. Now this point of intersection to be found. This point of intersection to be found, that is my E. So this is my E. We want to now find the feasible region. We want to find the maximum value of this function, of this objective function subject to the two constraints. So first of all, where these two constraints are sync, so that we can identify where it is. For an example, AB, first equation, it is 3x1 plus 2x2 is less than or equal to 48. Always you take origin. You take 0, 0 for finding feasible region. If I take 0 here, 3 into 0 plus 2 into 0 is less than or equal to 48. I mean 0 is less than 48. If 0 is less than 48, what does it mean? It satisfies. It satisfies towards origin. Therefore, you can give a shading like this. You can give a shading like this. If you come to this thing, second equation, if I take, it is x1 plus x2 is less than or equal to 20. Again, you take the same origin. 0 plus 0 is less than 20. Yes. 0 is less than 20. Hence, a shading should be given like this. Shading will be given like this. Where these two are intersecting. Where these two are intersecting. I mean, feasible region, common region. To find the common region, what is a common region? Two lines are intersecting at origin C, E, and then B. Am I right? Common region will be OCEB. Have you understood till this? Have you understood till this?
Yes, sir.
Sir.
Any questions? Okay, to find E, that is point of intersection to be found. Point of intersection means we have to solve these two equations. We want to solve these two equations. They are not identical. So I want to multiply 3 in the second constraint. I want to multiply 3 in the second constraint so that this is 3x1 plus 3x2 is equal to 60. Whereas it is 3x1 plus 2x2 is equal to 48. So you subtract so that x2 is equal to 12. If x2 is 12, what can be x1? Substitute in any one equation. Suppose if I substitute here 3 into x1 plus 2 into x2, which is equal to 48. So 3x1 is equal to 24. X1 will be equal to 8. So we found the point of intersection E as 8, 12. Now we want to find the result. What is the result? I told you already, feasible region is this. C, E, and then B. Where is O? If you ask, it is an origin. Origin cannot be a maximum. At 0, 0, it is minimum, you know. X 22 into 0 plus 8 into 0 will be 0. So at C is 0, 20. C is 0, 20. Substitute in the objective. 22 into 0, 18 into 20 will be 360. Take E, 8, 12. Substitute 22 into 8 plus 18 into 12. Total 392. B, 16, 0. So 22 into 16 plus 0. So this is 352. So where this attains a maximum? Z attains its maximum at E, 8, 12. Because the value seems to be maximum only when 8, 12, that is 392 is a value. Have you understood the result? Have you understood the problem?
சார் எனக்கு அந்த லாஸ்ட்ல மல்டிப்ளை பண்ணி ஆட் பண்றது மட்டும் புரியல சார்.
You found the feasible region OCEB. You found
Yes,
the
sir.
multiple region OCEB. Take that coordinate C, substitute in your objective. So this objective is your main in the problem. So we are
Yes, sir.
taking this objective function where we are substituting this common region extremes. So why are we bothering about extremes? Why didn't we bothering? I mean, why don't you bother about these terms? In these terms, why don't you bother? Because your maximum minimum always goes in the extreme points. I mean, boundaries. It is not in this region, but we have to find the common region. To the common region, we will identify where the spot is. Next, your maximum minimum value will occur only in the extreme boundaries. That is why we are focusing on OCEB. Is that clear?
Yes, sir.
The same way we will solve the next problem. We want to maximize. Again, objective is a function to maximize. Objective of the problem to maximize. No right hand side is negative. No right hand side is negative. Step number 1, what I have to do? Take x1 is equal to 0. What is x2? 10 by 3. Take b. B is x2 is equal to 0. What is x1? It is 5 by 2. 5 by 2 means 2.5. 10 by 3 means 3.333. So where does it intersect? So your AB will be this. Your AB should be this. Your AB should be this. The next is next constraint is this is B of what is that? When x1 is equal to 0, sorry, not B, it is C of 0. When x1 is equal to 0, what is x2? I mean, in this constraint substitute. In the same way, you take this one. When x2 is equal to 0, what is x1? So connect these 2 points, C and D, by a line. Now where the feasible region is? Your first line 4x1 plus 3x2 is less than or equal to 10. If I take 0 plus 0, this will satisfy. Origin test is satisfied by this line. So these two are the common region. I mean, feasible region. In the same way, if you
sir, that C how you are finding, sir? C and D.
Take the second constraint. Take a first constraint. Substitute x1 is equal to 0. If x1 is 0, what is x2? 3x2 is 10. x2 will be 10 by 3. When x2 is 0, what is x1? 10 by 4. 10 by 4 is 5 by 2. In the same way, take a second constraint. x1 is equal to 0. What is x2? 5. When x2 is 0, what is x1? 10. Is that clear?
Yes, sir.
So here we want to find the feasible region for the second constraint. This is also a constraint which satisfies the origin. 0 plus 0 is less than 10. Hence, I can give a shading towards origin. You can give a shading towards origin. What is a common point? What is a common region? The common region
OCD,
will
sir.
be OAB. OAB. Because the two lines intersects at OAB. Is that right? Two
Yes, sir.
lines
OAB.
intersects only in this. Two colors intersects only in this part. So you take at origin. At origin 0, 0, you know obviously this is 0. At A, substitute in your objective. In objective, this is 0 plus 10 into 10 by 3, which is 100 by 3. The last case B, 5 by 2 comma 0, substitute here 25 into 5 by 2 plus 0. I will get 125 by 2. Is that, have you all understood? Now, of the 3 points, which is maximum? Of the 3 points, which is maximum?
125 by 2.
120. So Z attains maximum at 125 by 2. Do you able to solve this problem if it comes to exam?
Yes, sir.
Yes, sir.
In the same way, third question. We want to minimize. So far, we have discussed the maximization problem. Now the objective is minimization with 3 constraints. Now objective is minimization with the 3 constraints. So let us do one by one. Minimization problem. No right hand side is negative. No right hand side is negative. Take a first constraint. Take a first constraint A. I mean first constraint, if I take A, x1 is 0, what is x2? 40. In the same way, take x2 is equal to 0, what can be x1? 20. Because if x2 is 0, 2x1 is 40, x1 will be 20. Second line, if I take, second constraint, where if I take x1 as 0, what is x2? 25. Because 2x2 is 50, x2 will be 25. In the same way, if I take x2 is 0, x1 will be 50. And the last constraint will be direct. When x1 is
CD
0,
வரல.
x2 is
CD.
okay. Okay. This is CD. This is EF. So this is 35. 35 0. Is it? Have you all understood? Shall I go to next step?
Yes, sir.
Yes, sir.
Now you plot this line. Then only we can decide the shading. 0, 40, 20. So A is this. Give a shading. Where the shading can come. This is 2x1 plus x2, which is more than or equal to 40. 0 plus 0 cannot be greater than 40. Therefore, shading should not be given towards origin. Shading should be given away the origin. I mean, it will go like this. Shading will go away the origin. It should be like this.
Sir,
Hmm.
one boy Sudan is waiting, sir.
Already I have given this email ID link. Why are they irritating me? Why didn't they use it? Sir. Okay, next constraint is C and D. CD means I should take this. So where the shading should be. Again, it is a second constraint 2x1 plus x2 is greater than or equal to 50. 0 plus 0 cannot be greater than 50. So I cannot again give a shading towards an origin. What I have to do? Shading should be given away the origin. So it will be like this. You have to tell me now the common region So where is the common region? A, B, C, D, E, F. I can say this is G. I can say this is my, okay.
Sir, sir, there's still one more line left, sir. Sir, common line.
Correct. But before this, these are the common points. One A, another one is D, and one more point is this. So far these are the common points where it intersects. Last line is E and F. EF means so this is my EF. Again, 0 plus 0 cannot be greater than 35. So what I have to do? I should again give a shading away the origin. It should be like this. Now can you tell me this common point? Where all the three lines meets. Before this I complete. What are the point of intersection? A, B, C, D, E, F. This is your G. This is your H. This is your I. Yes. Now you can tell me the common region. Where the common region is?
GHI, sir.
Common region is, in fact, you can
GHI.
take A, G, I, H, it never come, and then D. Am I right?
Yes, sir.
Because here I don't get the red line. In this triangle, I don't get a red line. This will not come. So A, G, and then I, then D. F will not come. E will come. Anyhow, I try to settle this. A, G, I, D. So we have to find these 2 points of intersection. The point of intersection of G as well as I to be found. To find G, how do we solve? Which line I supposed to take? One is AB, another one is last 2 lines to be taken. These are the 2 lines I supposed to take. So 2x1 plus x2 is equal to 40. Whereas this line will be, take these 2. Because this is your AB. G intersects between red and blue. So red is first line, red is the last line, blue is the first line. So I can take 1 and 3, solve for x and y. Can I directly subtract? If
Yes,
I
sir.
subtract
Cancel
this, what do
x2.
you get? Your x2 eliminates, what is your x1? x1 is 5. If x1 is 5, what is x2? x2 will be equal to 30. If x1 is 5, therefore x2 will be equal to 5 plus x2 is equal to 30. This implies x2 is equal to 30. If x2 is 30, then G will be 5, 30. In the same way, to find D. D is an intersection. No, D is there. Why should I want to find? I have to find only I. To find I, it's an intersection of CD, second line. Then, these 2 lines should be solved. x1 plus 2x2 is equal to 50. This is x1 plus x2 is equal to 35. So if x2 is 15, therefore what is x1? X1
20,
will
sir.
be equal to 20. So your I is 20, 15. So we found everything. All the point of intersection have come, feasible region have come. Now at A 0, 40. At A 0, 40, what is your objective? It seems 120 because it is equal to 4 into 0 plus 3 into 40. So this is 120. Second case G, which is 5, 30. At 5, 30, what it calculates? This is equal to 4 into 5 plus 3 into 30, you get 110. At I 20, 15, this is 4 into 20 plus 45 plus 80, 125. Last case is 250, 0. I mean F is 50, 0. Where it attains the minimum, because our objective of the problem to minimize this. So Z attains the minimum at in this point. Is that clear? Have you understood?
Yes, sir.
The graph scale, I suppose you should. The graph scale, you can see how to compute. You should see what is the maximum value, minimum value. You should see what is the maximum value in X, maximum value in Y. Based on that, you can take 5 units, 2 units, 3 units, I suppose. So scale in x-axis should be equal to scale in y-axis. If I take 5 units in x-axis, then I should maintain the same 5 units in y-axis. If I take 2 units in x-axis, I should maintain 2 units in y-axis. So please aware of this. How to compute the scale in the graph. So this is another problem. We want to maximize the objective of the problem subject to the first constraint. It is a mixed constraint. So far we discussed less than or equal to type in the first two problems. Third question is more than or equal to type with the minimization. Now it is a mixed constraint, objective of the problem to maximize. Subject to 3 constraints are given, like first, no right hand side is negative. Then take x1 is equal to 0, what is x2 for the first line? Take x2 is equal to 0, what is x1 for the second line? Find this. In the same way, take x1 is equal to 0, what is x2? Take x2 is equal to 0, what is x1? Find this. For the third constraint, take x1 is equal to 0, what is x2? Minus 2. Take x1 is equal to 0, what is x2? It is 2. And the last one is more than 4, that to x1. So x1 equal to 4 means x1 equal to 4 means it is an equation of x-axis. X1 is equal to 4 means it is an equation of x-axis. Have you first understood this 3 steps?
Yes, sir.
Now we want to plot this line. Now we have to plot this line. First line is 0, 8 and 10, 0. So you know what is the scale now. Maximum value in the x is 12. Maximum value in the x is overall it is 12. Maximum value in the y, it is 4, as well as minus 2 is minimum. So minus 2 means I should go to this, but still this will not come because we will take an answer in the first quadrant. But still it is negative, we have to assume this. First constraint is AB. So in AB, connect A and B. So we connected A and B. How the shading to be? Where the shading should be given? 4x plus 5x2 is less than or equal to 40 means 0 plus 0 is less than 40. So origin test satisfies. Hence, I can give a shading towards origin. So give a shading towards origin. Second case, 0, 4 and 0, 4 and 12, 0. I suppose C and D will be this. So now again give a shading like this. What is your next line? Minus 2 and 2. So the shading should be this. Minus 2, 2 means you should take this constraint. 3x1 minus 3x2 is more than or equal to 6. Again, you take the same origin test. 0, 0 is never be greater than 6. 0 cannot be greater than 6. Therefore, shading will come below the line, something like this. It will come below the line because origin does not satisfy. Have you understood?
Yes, sir.
Yes, sir.
Yes, sir.
The last case is x1 is equal to 4. The last case x1 is equal to 4 means it's a line parallel to y-axis. It is a line parallel to this is my x1 is equal to 4. Now, more than 4 means where the shading to be. It will come like this. Am I right? You can give a shading like this. Now, of the 4 colors, all the 4 colors where it intersects. What is the common region? Where all the 4 colors intersects. Now, before getting into this, the A, B, C, D, E, F, G, this is one point of intersection, H, and then I. There is a triangle. This is one point of intersection, 1. This is another point of intersection. This is another point of intersection, A, B, C, D, E, F, G, H. It is my I. It is my J. This is my K. This is my K. So, of the where all the shading intersects.
Sir, above I, there's also another point, sir.
Yes, this is also there. I, J, and then K, L, and then M. Anything else missed? Okay. Now, can you tell me what is the common region?
GH
This is
and then I.
great.
Sir, GJILKB, sir.
G, J, I, K, that's it, KB. So this is my common region. So what I want to now find, this common region means this point of intersection to be found. So to find the point of intersection of J. Once if I find this J and I, problem is over. To find J and I, we have to solve this. Okay. To find J means it is x1 is equal to 4. That is one line. This is intersecting with the red color. Red color means E and F. So these two lines should be solved. These two lines should be solved. That is 3x1 to find J. What I want to do, this line, red color. E and
Red
F.
and black.
Red and black. Okay. Take x1 is equal to 4. 3 into x1 minus 3 into x2 is equal to 6. x1 is equal to 4. If I substitute, what is x2? 12 minus 3 x2 is equal to 6. This implies x2 will be equal to what is x2? Three x2 is equal to 6. X2 will be equal to 2. If x2 is 2, then j will be equal to 4 comma 2. J is equal to 4 comma 2. So g, j, I to be found. To solve I and j, I mean to solve this I, red color and green. Red and green means CD. I mean these two lines should be solved. These two lines should be solved. To find, so we have to multiply this. You have to multiply. Also, we want to find k. So 3 point of intersections to be found. Okay. What is the next point of intersection? This is to find G. This is to find J. Next to find K. To find K, what I want to do? To find K, what I have to do? Yes. To find K, you have to solve first two equations. You have to solve these two equations. I eliminate x1. I multiply 2 with the first equation. It is 8x1 plus 10x2 is equal to 80. I multiply 2 with the first equation. I multiply 4 with the second equation. I mean, if you multiply this with 4, if you multiply this with 2, now what do you get here? It is 8x1 plus 24x2 is equal to 96. Now you eliminate x1. So what do you get for x2? Minus 14 x2 is equal to minus 16. x2 will be equal to 8 by 7. x2 is 8 by 7. What is x1? So x1 will be equal to x1 is equal to, substitute in any one of the equation, 4x1 plus 5 into x2 is 8 by 7 This is equal to 40. 4x1 is equal to 40 minus 40 by 7. 4x1 is equal to something else. So x1 will be equal to 60 by 7. Then you will get what is this k? K is 60 by 7, comma 8 by 7. And the last case is to find what? To find I. To find I, what I have to do? You have to solve these two equations. So multiply with 6. You multiply 3 with the first equation, 2 with this equation. You multiply 3 there, it is 6x1 plus 18x2 is equal to 72. If you multiply that with 2, 6x1 minus 6x2 is equal to 12. So solve for x1. So subtract plus minus. I get x1 is equal to 24, x2 is equal to 60, x2 will be equal to 2.5. If x2 is 2.5, substitute in any one equation. That is 3 into x1 minus 3 into 2.5 is equal to 6. So x1 will be equal to 4.5. So my I coordinate will be 4.5 comma 2.5. So we found everything. We have to now come to the result. What can be the result? So the result is this. I come to the result. You know what are the coordinates? G, coordinates z is equal to 4x1, sorry, 2x1 z is equal to 2x1 minus 3x2. What is the first one? G. What is the coordinate of G? G is 4 comma 0. If I take 4 comma 0, this is 2 into 4 minus 3 into 0. This will be equal to 8. The second case is J. So J is missing. Okay, J is found. Now only J is 4 comma 2. It is 2 into 4 minus 3 into 2. So how much do you get? 2 into 4, 8. 8 minus 6, this will be equal to 2. Then J is over. What is I? I is now only we found 4.5, 2.5. If I take 4.5, 2.5, 2 into 4.5 minus 3 into 2.5, how much do you get? It is 1.5. What is the next case? GJI K. What is the coordinate of K? 60 by 7, comma 8 by 7. So 2 into 60 by 7 minus 3 into 8 by 7. It is 13.7. And the last case is B. What is B? What is the coordinate of B? 10, 0. So 2 into 10 minus 3 into 0. So answer is 20. Z attains the maximum at this point. Z attains
Sir, where is A, sir?
maximum. Why should I want to take A? Why should I want to take A?
There is no need, sir.
It is not in my purview at all. The common region, I take only which is having a maximum. This A is not in my purview of the common region.
Okay, sir. Okay.
So Z attains the maximum only in this point. So that is it. Have you all understood how to catch point of intersection, etc.?
Yes, sir.
So this is another problem. It is also a mixed constraint. It is also a mixed constraint of this. What is the first one? If you take x1 is equal to 0, what is x2? 0, 50. If you take x2 is 0, what is x1? 40, 0. This is for the first line. For this line, see, when x1 is 0, x2 will be 30. When x2 is 0, what is x1? 50. The same A, B, C, D, E. So when x1 is 0, what is x2? 25. F, when x2 is 0, what is x1? 20. What about this case? When x1 is 0, EF, this is G. 0, 20. H, 10, 0. You can use a graph note if you want. In examination, graph sheet, sorry, being an online examination, you can use a graph sheet. Otherwise, if it is a normal examination, they will give you. So this is a usual maximization problem. No right hand side is negative. Hence, we shall start the problem. So what is the first line? AB. So AB is 0, 50, 40. So AB. Where do you give a shading? Where do you give a shading? Because 0 plus 0 is less than 200. Origin test satisfies. Therefore, the shading can be given like this. Because too many constraints are there, don't mistake me. That's why you use this different dotted lines. Okay. Second line. What is the second line? C and D. C and D. C is here, D is here. D is here. C is here. So how do you give a shading for C? I give a shading like this. Now so far it is a quadrilateral. Common region comes in the quadrilateral. Not a quadrilateral. 1, 2, 3. Yes, it is a quadrilateral. What about the third line, E and F? E and F is this 25 and 20. And 20. How do you give a shading? So this will satisfy origin test, whereas this will not satisfy origin test, because 5 into 0 plus 4 into 0 cannot be greater than 100. So what I have to do? It should go away the line. So away the line means it will take like this. Now can you tell me where is the common region? Now can you tell me where the common region is? This is a common region, am I right?
Sir, GH.
Is a common region.
Sir, GH portable.
இன்னொரு லைன்
So far what is the common region? I know one more line yet to do. So far what is the common region?
சார் அந்த நடுவுல இருக்கிறது தான் சார்.
Then a common region.
Yes, sir.
So what is the last line? G and H. G anger ke H anger. Okay, G is here, H is here. Take G is 20 and H is 10. G is 20, H is 10. Now where the shading is? It is also, it doesn't satisfy origin test. It is not greater than 80. Therefore the shading will go away the line. The shading will go away the line. So away the line means now where all the four are intersecting. Now where all the four are intersecting. Is it not this one? All the four are intersecting at this. Sorry.
Yes, sir.
This is a common region, I suppose. I have to name it. A, B, C, D, E, F, G, H. I call it as I. So we want to just find what is I. So the common region is CI, CI and then B, then F, then E. So to find I, what I have to do? I is a intersection of A, B and C, D. First two lines to be solved. Multiply this with 3, that with 5. So solve first two equations. 15x1 12x2 is equal to 600. It is 15x1 plus 25x2 is equal to 750. So cut this. Minus 13x2 is equal to minus 150. So x2 will be equal to 150 by 13. If x2 is 150 by 13, what should be x1? X1 will be equal to 400 by 13. It is 5x1 plus 4 into x2 is equal to 200. This implies x1 will be 400 divided by 13. You verify whether do you get. So we found what is I. So I is 400 by 13, comma 150 by 13. So what is the result? What is the result? So the result is this. So what is the result? It is a C, then I, then B, then F, then E. What is C? I just directly write because your objective is 300 x1 plus 400 x2. At C, what is the answer? At C, what is the answer? It is 300 into 0 plus 400 into 30. It is 12,000. At I, what is the answer? I is 400 by 13. So this is 1,80,000 divided by 13. At I. B and F to be done. At B, it says 12,000. At F, it says 6,000. At E, it takes 10,000. So of the 5 outputs, which is the maximum? Z attains the maximum at this point. Z attains maximum at this point. Have you all understood? Have you all understood?
Yes, sir.
So this is a common region for this problem. This is a common region for this problem. This polygon. This polygon is a have you all understood?
Sir. Sir.
If you have any doubts, you may ask.
அது நம்ம அந்த கிராஃப் வச்சு பிளாட் பண்ணிடலாம் சார்.
பண்ணலாமே, கிராஃப் வச்சு பண்ணலாமே.
ஓகே சார்.
With this I complete today.
சார் கிராஃப் போடும்போது இந்த மாதிரி தனியா வேற கலர் போடணும்னு அவசியம் இல்லைல்ல சார்?
சரி, நான் உங்களுக்கு புரியறதுக்கு நான் எப்படி எடுக்கிறது? இங்க கலர் எடுத்து தான் பண்ணணும்.
எஸ் சார்.
உங்களுக்கு எக்ஸாம்ல இந்த கலர்லாம் போட வேண்டாம்.
ஓகே சார்.
சார் இது 5 மார்க்கா 15 மார்க்கா சார்?
எதுல வேணாலும் வரலாம். சிம்பிளா வந்ததுன்னா 2 கன்ஸ்ட்ரெயின்ஸ்லாம் வந்ததுன்னா 5 மார்க். மோர் தென் 2 கன்ஸ்ட்ரெயின்ஸ்லாம் வந்ததுன்னா 15 மார்க் தான்.
எஸ் சார். தேங்க்யூ சார்.
Thank you, sir.
Thank you.
Thank you, sir.
தேங்க்யூ சார்.
Thank you.